Hello students, welcome back to today's class on exponents and powers, and today we're having a practice session. Let's try to discuss more advanced applications on all the exponents and laws that we have discussed in the previous classes, right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So the first one that we're going to discuss, once again, let's try to have a small recap of all the formulas which we discussed in the last class, which is a power m into a power n is a power m plus n. A power m by a power n is equal to a power m minus n. A power m whole power n is a power m into n. You need to multiply these two. You don't add these two, right? Here you need to add, don't multiply. So there is a bit confusion between these two always. Next, a power m into b power m. Exponents are same, powers are same, but not the bases. So we say ab whole power m. Okay. So ab, we can multiply these two whole power m, and a power m by b power m, which is a by b whole power m. A by b whole power m. Okay, moving ahead. So let's try to discuss a few notations which we have already discussed in previous classes about squares, square roots, cube roots. In that way, let's try to discuss more about exponents. Okay, root a is actually equal to a power 1 by 2. A power 1 by 2 is written as root a. For example, I have root 25, which is written as 25 power 1 by 2. 25 power 1 by 2. Then we can apply exponents of laws if you have multiplications or divisions, whatever it is. Now you have x cube, and this root over is nothing but power 1 by 2. That root over is nothing but power 1 by 2. That will give you x power 3 into 1 by 2, x power 3 into 1 by 2, which will give you x power 3 by 2, which will give you x power 3 by 2. Okay, so that is how you can try to find, you can try to write exponents and powers. Root a is 25 power 1 by 2, root x cube is x power 3 by 2. Next one. So we have a question here. Let's try to discuss some applications based on all this. X power a by x power b whole power a square plus ab plus b square, and similarly we have the other two terms. The first thing is you need to solve this one. Forget about the power. Let's try to solve this one. X power a by x power b. We know what is a power m by a power n, which is equal to a power m minus n. A power m by a power n is equal to a power m minus n. So that will give you x power a by x power b, x power a power m minus n, x power a minus b, x power a minus b whole power a square plus ab plus b square, right? And we also discussed what is the formula of a power m whole power n, which is a power mn. You need to multiply m and n. We need to multiply m and n. Okay, so that is equal to x power a minus b into a square plus ab plus b square. A minus b into a square plus ab plus b square. So this is the formula of, if you can remember the formula of a cube minus b cube, a cube minus b cube is equal to a minus b into a square plus ab plus b square. So that is the formula of a cube minus b cube, right? So here the same formula is appearing. So it is equal to x power a cube minus b cube. Now we have one more thing, x power b by x power c, which is into x power b minus c, x power b minus c whole power b square plus bc plus c square. X power b by x power c, x power b minus c power x square plus cb plus bc square. Let's try to erase this formula the same way what we have discussed the first term. We'll try to do the same thing even for the second term. Okay, so let's try to discuss that. So into x power b minus c into b square plus bc plus c square. Okay, so b minus c into a minus, this is again the same formula, a cube minus b cube. Here it is b minus c into b square plus bc plus c square, which is x power b cube minus c cube. X power a cube minus b cube, this is x power b cube minus c cube. In the same way, here we have x power c minus a, x power c minus a whole power c square plus ac plus a square, c square plus ac plus a square. So that will give you x power c minus a into c square plus ac plus a square, right? So that will give you into x power c cube minus a cube. into x power c cube minus a cube, right? So now we have the formula a power m into a power n, a power m into a power n, you know it is a power m plus n, and the same formula can be applied for any number of terms. Here you have 3 terms and still you can apply the same formula, just add all the powers. So that will give you x power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. So if you carefully observe, all a cubes and minus a cube, b cube and minus b cube, c cube and minus c cube, all these gets cancelled. You will get x power 0 which is equal to 1. You will get x power 0 which is equal to 1. Alright, so moving ahead, let's see the next question. Cube root of 4 whole power 2x plus 1 by 2. Cube root of 4 whole power 2x plus 1 by 2 is equal to 32. Then find the value of x. Okay, so how to get this one? Cube root of 4 whole power 2x plus 1 by 2. I said you can compare these two numbers if you have the same base or the same exponent, same powers or same base, then we can try to find these formulas. Okay, so what is the meaning of this one? 3 under root 4. What is this? 3 root 4. It is a cube root. Cube root, what do you mean by cube root? Power 1 by 3. Square root, I told you. Square root, root a, if you can remember, a power 1 by 2. Here it is a cube root of a. The 3 is inside this root over the bracket, in that V shape, like this. So it is a power 1 by 3. 4th root of a, which is a power 1 by 4. 5th root of a, which is a power 1 by 5. A power 1 by 5, right? So cube root of 4, which becomes a 4 power 1 by 3. 4 power 1 by 3 whole power 2x plus 1 by 2, which is equal to 32. What is 4 again? Okay, let us try to multiply these to a power m whole power n, a power m into n. That will give you 4 power 1 by 3 into 2x plus 1 by 2. 4 power 1 by 3 into 2x plus 1 by 2 is equal to 32. Right, 4 power 1 by 3 into 2x plus 1 by 2 is equal to 32. Now, if you go for 4, you can write as 2 square. 4 you can write as 2 square. So 2 power 2 into, or 2 power 2 whole. Will not delete the steps. Let's try to write it. 2 square whole power 1 by 3 times of 2x plus 1 by 2 is equal to 32. Right? So let me erase these things. So now, how to write 32? How to write 32 so that we can compare the bases. We can equate the bases and compare the remaining things. So you know 32 is 2 power 5. I'll tell you how is that. 32, for example, 32, it is 2 into 16, which is 2 into 8, which is 2 into 2 into 4, and again 2 into 2 into 2 into 4 is again 2 into 2, so which is 2 power 5. 32 is 2 power 5, correct? 32 is 2 power 5. So now we can see here a power m whole power n. A power m whole power n, a power mn. So 2 power 2 into 1 by 3 into 2x plus 1 by 2, right? 2 power 2 into 1 by 3 into 2x plus 1 by 2 is equal to 32, which is 2 power 5. 32, which is 2 power 5, right? So 2 by 3 into 2x plus 1 by 2 is equal to 5. 2 by 3 into 2x plus 1 by 2 is equal to 5. So 2x plus 1 by 2 is equal to 5 into this 3 will come here up and down 5 into 3 by 2. Right? This 3 which is in the denominator goes to numerator, and this 2 in the numerator will come into denominator. So that will give you 2x plus 1 by 2 is equal to 5 3 is 15, 15 by 2. So 2x is equal to 15 by 2, and plus 1 by 2 we have minus 1 by 2. 2x is equal to 15 by 2 minus 1 by 2. 15 by 2 minus 1 by 2, which is a 14 by 2. 2x is equal to 14 by 2, and that will give you 7. 14 by 2 will give you 7, right? So 2x is equal to 7, and you'll get x is equal to 7 by 2. X is equal to 7 by 2. Okay. So once again, let's try to discuss all this carefully. Cube root of 4. What do you mean by cube root of 4? Which is a 4 power 1 by 3. 4 power 1 by 3 whole power 2x plus 1 by 2 is 32. So once you solve that and you write 2 power 5, equate the exponents because the bases are equal. because the base are equal, you can equate, right? So from there you will get the value of x as 7/2. Very beautiful problem. Just try to copy that whatever you want, and let's move for the next question. So quickly copy for the next 1 minute, or take a screenshot or whatever the sources you have, so that we can move for the next question, right? So once again, please cross check that. If there is any mistake that has happened here, please try to rectify that, try to solve that again, and try to bring the correct answer yourself. Okay, so that will give you 7/2, right? Okay, so moving forward, the next one, 1/1 plus x power a minus b plus x power a minus c plus x power b minus c, x power b minus a, c minus a and c minus b. It's a very important question and very interesting question. You can see here, a power m minus a power n. What I'll do, I'm not doing this complete thing. I'll just try to solve the first one. From there we can write what is the answer for the second one. From there we can write what is the answer for third one, and let's try to combine all these together. The very first one we're going to do. So we have 1, here it is a minus b, here it is a minus c. Let me do that, okay? So 1/1 plus x power a by x power b plus x power a by x power c. So what is the LCM in the denominator? X power b and x power c, x power b into c, x power b into x power c, 1 by, okay, it is x power b into x power c, x power b into x power c. So this is again 1. Right? So 1 times x power b into x power c, and the same thing will come here, x power b into x power c plus x power b is already here, so x power c is left, x power c into x power a, x power c into x power a plus x power c is here, x power b, x power b into x power a. Right? So this term in the denominator gets reciprocal and goes to the numerator. That will become x power b into x power c by x power b into x power c plus x power c into x power a plus x power b into x power a. So this is how the first term goes. This is how the first term goes. So it is x power b plus c, x power b plus c by in the denominator it is in x power b plus c plus x power a plus c plus x power a plus b plus x power a plus b, right? So this is the answer. This is the answer for the first term. Using this answer, we need to write for the second and third terms as well. So carefully see here how to write. X power b plus c, this is the b and this is the c. For the next one, you'll get c plus a, the next one you'll get c, a plus b. So you need to understand how we are getting those terms. Denominator, you have all the combinations. You have a plus b, b plus c, c plus a. All three combinations will be same for all the three terms. If you are confused, just try to do the remaining two also in the same manner. The same manner, please try to do the remaining two terms. Okay. The first term we are getting x power b plus c. This is equal to x power b plus c by x power a plus b plus x power b plus c plus x power c plus a plus, okay, plus x power, now this c and this a will come here, a plus c by the same denominator will come x power a plus b plus x power b plus c plus x power c plus a plus, right? Denominator again we have x power, so it is x power, the same thing, x power a plus b plus x power b plus c plus x power c plus a. Numerator we have a and b, so it is x power a plus b. Here it is x power a plus b, right? So now if you take the LCM properly, if you take the LCM properly, it is x power a plus with same LCM, right? X power a plus b plus x power b plus c plus x power c plus a, and the numerator you have x power b plus c plus x power a plus c plus x power a plus b, and if you carefully compare, carefully see the numerator and denominator, both the terms are same, and you can cancel the complete term and you get the final answer as 1. See how beautifully this question is framed. Even though we have discussed a long solution for this one, we finally got a simple answer which is 1, because the complete term, the complete numerator and complete denominator both are same, and so we are getting the answer as 1. Clear? Okay, the next one. Okay, again 1/2 whole power x minus 2 is equal to 102 for a very beautiful question. 1024. This is enough to say that it's something related to, because it is a 1 by 2 here. 1 by 2 is 2 power minus 1. 2 power minus 1 whole power x minus 2 is equal to 1024. 2 power minus 1 into x is minus x, minus 1 into minus 2 is a plus 2. 2 power minus x plus 2 is equal to 1024. 2 power minus x plus 2 is equal to 1024, correct? Now, let's try to discuss about this 1024. Let's try to discuss this about 1024, okay? So, 1024, 2 ones, 2 5s 10, 2 into 5 is 10, okay? So, 2 ones are 12 and 2 twos are 4, so 5, 1, 2. Next, 2 times 2, 4, 2 twos are 4, 1, 2 5s are 10, 1 again, 2 6 are 12. Right? Once again, 2 ones, 2 twos, 4, 1, 2, 8, 16. Again, 2 ones, 2 6 times 12 and 4 times are 8. 2 32 times, 2 16 times, 2 8 times and 2 4 times and again 2 2 times. So now tell me how many 2 are how many 2s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is one more 2 there. So 1024 is nothing but 2 multiplied 10 times, which is 2 power 10. 2 multiplied 10 times, which is 2 power 10, right? So 2 power minus x plus 2 is 2 minus x. 2 power 2 minus x is equal to 2 power 10. 1024 is 2 power 10, okay? So 2 minus x is equal to 10. 2 minus x is equal to 10. So now carry forward this x to the other side and 10 to the other side. This side 2 minus 10 is equal to x and so x is equal to 2 minus 8 is minus 8. Minus 8. Once again, carefully check that. Minus 1 whole power x minus 2 minus x minus 1 minus 2 is plus 2. 2 power 2 minus x is 2 power 10. 2 minus x is 10 and 2 minus 10 is x. So from here you get x is equal to minus 8. You will get x is equal to minus 8, right? So you can verify that by keeping x equal to minus 8 back in the equation. 1 by 2 whole power x is minus 8 minus 2. 1 by 2 whole power minus 10. 1 by 2 is 2 power minus 1 whole power minus 10. So which is 2 power 10 a power m into n, right? So yes, this has been verified. So what is the answer of x? X is equal to minus 8. X is equal to minus 8, right? So moving ahead, let's move for the next question. X power 1 by 3 minus 2 into x power 1 by 3 plus 2 is equal to 5, and the value of x is. The question here is, it is of the form a minus b into a plus b, and you know the formula of a minus b into a plus b, which is equal to a square minus b square. You know what is a minus b into a square, a plus b, which is a square minus b square, which is x power 1 by 3 whole square minus 2 whole square, which is equal to 5. X power 1 by 3 whole square minus 2 whole square, which is equal to 5. So which is x power m whole power n. X power m whole power n, which is x power mn. Multiplication of 1 by 3 into 2 becomes 2 by 3, right? Minus 2 square is 4 is equal to 5. X power 2 by 3 minus 4 is equal to 5. So x power 2 by 3 is equal to 5 plus 4. 5 plus 4 is equal to 9. 5 plus 4 is 9. So x power 2 by 3 is equal to 9. Now, how to compare these two? 9 we can write as 3 squared. So what happens if we write 3 square? This x power 2 by 3 we can write x power 1 by 3 whole square is equal to 3 square. So now it is enough to compare because the powers are equal, the bases should be equal. So I can say that x power 1 by 3 is equal to 3. And now tell me how to find the value of x. Cubing on both sides. We do cubing on both sides so that we can eliminate that 1 by 3. Okay, what is a cubing? X power 1 by 3 is equal to 3. So we'll power 3 on both sides. We'll do a power 3 on both sides. So 3 and 3 gets cancelled. X is equal to 3 cube. 3 cube is 27. So finally the value of x is 27. The value of x which satisfies this equation is 27. Clear? X power 1 by 3 minus 2 into x power 1 by 3 plus 2, which is 5. So x equal to 27 satisfies that equation. Okay, next one. Again, the same thing, we get the value of 2 by 3, but here the exponent, the power is 1 by 3. The power is 1 by 3, okay? So I'll just give you the hint what to do. As we have 1 by 3, again, cubing on both sides will apply. So, cubing on both sides, x plus 1 by x plus 20 whole power 1 by 3 cube of that, okay? Cube of that will give you 2 by 3 whole cube. Will give you 2 by 3 whole cube. Okay, so 3 and 3 gets cancelled. You will get x plus 1 by x plus 20 is equal to 2 cube is 8 by 3 cube is 27. So now you need to solve for this one. You need to compare these two. You need to cross multiply and try to bring the value of x, right? Okay, you can simply do that. So one more question. X power 1 by 4 is 4, y power 1 by 2 is 3. Then we need to find the value of this one. X power 3 by 4 is something like x power 1 by 4 whole cube. And y power 5 by 2 is y power 1 by 2 whole power 5. So these two values are there with you. You can just simply substitute and you can try to find the value of x and y, right? So we have discussed very beautiful questions in this chapter, exponents and powers. In the coming lecture, we're going to discuss more applications and more advanced questions like this, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone, so now we'll be discussing about earthquakes. Okay, my name is Session Reddy, I'm a graduate from IIT Dhanbad. Let's go into the class. So to understand earthquake, we have to understand a bit regarding the earth. So if I cut the earth, I mean we can't actually, but let's say if you cut the earth and look into it, there are four main parts that we can see. There are four main parts that we can see. What are they? The one that we are living on, okay, the ground basically, that is the crust. So from the surface, the first part will be the crust, then comes mantle, outer core and inner core. So the inner core is very hot, very hot. Okay, then comes outer core, hot, and mantle is also hot. So you have four main parts. So when you cut the earth, we get these four main parts. Now, why is this important when it comes to earthquake? Why? I'll give a simple explanation. Understand this. Okay, let's say there is a river or any ocean. Okay, doesn't matter. Then there are two boats. There are just two boats floating side by side. Okay, two boats floating on the river side by side. Let's say by accident they touch each other. Not very hard, even very lightly. Two boats, even by accident, if they touch each other, will anything happen? At least, will the people standing on the boat, will they shake? Will the boat shake or will the people standing on the boat shake? Imagine, two boats floating on the water. By accident, they touch each other, they collide with each other. Then, do the boats shake? Do the people standing on the boat, do they feel that shaking? Yes or no? Yes, they do it. They do feel it. Yes or no? The same thing happens with earthquake also in very simple terms. What exactly happens is, if we come back to the crust. Now crust is not continuous. Crust is in fact made up of parts. Different parts. You can say one part is this, the other part is this. And all of them will be floating on mantle. They are floating. So our ground that we can see, it's like a ship. The ground that we can see, that we stand on or we build buildings on, is like a ship, a boat. It is floating on mantle. It is floating on mantle. And the crust is made up of different parts. You can say different ships. So when two parts collide, when two ships collide, they shake, and that shaking is nothing but earthquake. Earthquake. Okay. So there are many reasons that can happen. One of the very agreed reason, okay, many scientists agree with this reason, is this. So let's look at this animation. I'll explain what is happening, but let's first look at this. So here the outer layer that is shown is crust. What is that? Crust. As you can see, there are different parts. It is not continuous. There are different parts. There are different parts of the crust. And here below the crust, there is something that is flowing up and down. See, that is flowing in a cycle like a liquid. That is Earth's mantle. Okay. So the Earth's mantle, this is the crust. This is the mantle. So the Earth's mantle behaves like a fluid and is in continuous convection. Now look at this word convection. Have you heard about it any time? Have you heard about convection any time? Heat transfer by convection. In liquids and in gases, heat transfer takes place by convection. Right? Now the same thing happens here. Why? Because if I compare them, let's say this is the crust. This is the core. In between you have the mantle. In between you have what? You have the mantle. Mantle is like a fluid. Now comparatively core will be very hot and the crust will be cold comparatively. So here what happens is this part of the mantle is hot. This part of the mantle is what? Is cold. So automatically what happens is cold one comes down and the hot one goes up. That is convection cycle. If in a liquid there are different layers of temperature, or if at the bottom you have hot liquid and at the top you have cold liquid, cold one comes down and hot one goes up. Cold liquid comes down and hot liquid goes up. The same thing is happening here. The same thing is happening here. Right? You can see the cycle. Hot one is going up and the cold one is coming down. And it keeps on repeating. It keeps on going on. Okay. So you can see it in the sense the mantle. It in the sense the mantle. Its mantle is heated up at the core and cooled down at the crust. So crust is cold and the mantle, the core is hot. So it is cooled down at the crust and heated up at the core. This difference in temperature sets up a continuous cycle of mantle convection. We call it as mantle convection. Now why is this important? Because here you can clearly see when the mantle is going up, here at this point, see that clearly. Here I'll take an example, there. Look at that. The mantle is going up, yes or no? So when the mantle will be going up, it will apply pressure. It will apply pressure on the crust and it will try to break it. It will try to break it. That is one of the reasons why crust is not a single piece in different pieces. Okay, good. So that is the reason why we have different pieces. Each plate is called a plate. We call them as plates. As you can see, the crust is divided into different plates. Everyone, can you see them? Just read them here. One is the Eurasian plate. We have an Indian plate separately. Australian plate, African plate, North American plate, South American plate, Pacific plate, Philippine Sea plate, many different plates. Okay. So here the moving mantle exerts an upward force, upward pressure on the crust leading to rupture of the crust. Rupture of the crust into several parts. So a crust breaks into several parts and each part is called tectonic plate. This word is very important, tectonic plates. So again imagine it this way. Each of them is like a ship floating on water. But these plates are floating on mantle. These plates are floating on mantle, the Earth's mantle. Good? Okay. Now, these tectonic plates can be imagined to be floating on the mantle, as I told you. when two tectonic plates collide or slide against, slide against or move over each other, earthquakes are produced. What does that mean? How does it happen exactly? See, we might not be able to feel it, but that doesn't mean that they are not floating. Just a minute, sorry. Just a minute, everyone. Yeah. Okay, so here, look at the video. Let's watch the video and then you'll understand it clearly. Just watch it, okay? See those plates here. See those plates. Can you see them moving? One is going over the other. One is going above the other, right? I'll again play it to you. Yeah, again watch it. See them, they are colliding, they are sliding against each other in this case. Like, yes. Then one is going under the other, one is going above the other. Anything can take place. And when those things take place, what happens is earthquake. Okay? Just a minute. Understood? So they slide over each other. So imagine them as ships. There are many ships floating on water. When two ships collide, they shake. The same way, Earth is made up of many plates. Earth's crust is made up of many plates. And when two plates collide, one goes under the other, one goes above the other. The two plates slide against each other. Anything that happens, any disturbance, will lead to shaking of Earth's crust, shaking of Earth, and it's called as earthquake. And it's very, very, very dangerous. Okay? Tectonic plates. These tectonic plates can be imagined to be floating on mantle. I think we discussed that. When two tectonic plates collide or slide against or move over each other, earthquakes are produced. One example is shown here, they are colliding here. One example is shown here, they're just moving against each other, like sliding against each other. Right, and whenever anything like this happens, earthquakes occur. Good? Okay. So again, a simple map has been shown to you. Right, so how many events or how many earthquakes have been recorded? This only from 1963 to 1998. You need not remember this, you have to just look at this and appreciate the information. And there are how many? 3 lakh, huge, 3,58,214 events. 14 earthquakes have been recorded, where they have been recorded and all. If you can see it, the earthquakes are occurring at some particular places, at least most frequently. They are occurring at a few places. And if we check, these things will be the boundary of the tectonic plates. If I go into that, there will be the boundary of tectonic plates. See, these are the tectonic plates. Wherever you have the boundary, on those boundaries you will get what? Most number of earthquakes. Why? Because whenever two plates collide against each other, most of the shaking will be at the border of the plates. That is the reason why That is the reason why most of the earthquakes occur near the boundaries of tectonic plates. Okay? Good. Again, another animation of where the largest earthquakes of the past 100 years have struck. Largest, dangerous earthquakes. You can refer to the link, this link for the complete video. I just given you an information. Now see this carefully. These are the not the minor earthquakes, very dangerous earthquakes. So you can look at them, see them. All of them, almost all of them have occurred on the boundary of the plates. Yes or no? Boundary of the plates. You can clearly see them. And I am not saying all of them, I am saying almost all of them have occurred where? On the boundary of tectonic plates. So that proves us, that will show that shaking of Earth's crust is because of tectonic plates colliding against each other. Okay? Good. Again, something for you to understand, that's it. One point that you have to understand is most of the earthquakes occur near the boundaries of tectonic plates. Okay, Himalayas is one example, okay? Himalayas is a boundary. Himalayas is a boundary of what? Of the Indian plate. That's why many earthquakes occur on the Himalayas. Correct? Chalo. So seismic zone. Now what are seismic zone? A seismic zone or a fault zone, another name, is used to describe an area where earthquakes are likely to occur. Where earthquakes are likely to occur most of the time. And where is that? That is mostly the boundary of tectonic plates. They are generally located at the boundaries of the tectonic plates. You can see that. See here. All of them are what? All of them they are in a particular region. And what is that region? The border or the boundary between tectonic plates. Good? Okay. Now seismic zones in India, there will be different zones. We classify depending on how powerful, how dangerous the earthquake will be. You can see this zone 2, zone 3, zone 4, zone 5. Zone 5 would be the most dangerous. Then zone 4, then zone 3, zone 2. Zone 2 like the least dangerous, pretty safe. Okay, and as you can clearly see, zone 5, almost the complete northeast is in zone 5. Then we have some parts of the northern India also in zone 5. It's like basically it will be the part of Himalayas. And then zone 4 also you can clearly see. So the northern part near the Himalayas, it's pretty dangerous when it comes to earthquakes. Earthquakes occur frequently. That's why you might have heard in news, in Nepal, earthquakes occur frequently. You might have heard about it already, right? Because Nepal is on the Himalayas. That is the reason. Understood? So you can, this is only for your information sake. Different zones, you can just go through them. North India, right? Even Delhi comes under zone 4. That's why in Delhi also you get frequent earthquakes. And I can see the Gujarat run of Kutch. I think that region also is zone 5. Very dangerous. So very prone to earthquakes. But the Deccan Plateau or the southern India mostly, okay, this comes in the Deccan Plateau, it's pretty stable. So not many earthquakes in that region, so it's mostly zone 2 or zone 3. Okay, pretty safe when it comes to what? Earthquakes. Got it? Only for information sake. This is only for information sake. Zone 5 very high risk zone as we discussed. Zone 4 high risk, zone 3 moderate risk, and zone 2 low risk. Got it? Good. Next. So there are some terms regarding earthquakes that we have to know about. What are they? This image will show you everything. So we'll discuss each and every term one by one. So first comes what? First comes something called as focus or another name hypocenter. Focus or another name hypocenter. Focus is the frequent name. So focus is the point where the earthquake originates. Focus is a point where the earthquake originates, where the two crusts actually collide, where the disturbance occurs. So the point within the earth where an earthquake rupture starts, that is focus. Then we come across epicenter. What is epicenter? Epicenter is directly above. So if this is, let's say this is the ground, somewhere here earthquake has occurred, focus. So the most of the damage will be where? Most of the damage will be directly above. Closer it is to the focus, more the damage. If it is more close to focus, the damage will be more. So here this point which is directly above the focus, that is epicenter. And focus will be inside the earth, deep inside the earth. But epicenter will be on the ground. You can say epicenter is, let's say, Bihar. It's like Nepal, Kathmandu, a region. We take it as a region. Okay. So The point on the surface, look at that, the point on the surface of the earth directly above the focus. And most of the damage occurs at the epicenter because that is the place where most of the damage will occur. Why? Because it will be most powerful. What will be most powerful? Earthquake will be most powerful near the epicenter. Okay? Good. So focus and epicenter, two important points, understood. Next, fault. Now what is fault? Okay, fault is a fracture or the line along which earthquake occurs. The fracture in the rocks that make up the earth's crust. So this line is nothing but the fault line. The boundary between the two crusts. The boundary between the two crusts where the earthquake occurs, that is the fault line or fault. Okay. Then you have seismic waves. Now earthquake spreads when two, I told you right, shaking spreads. When two ships collide, the complete boat shakes. That means that disturbance is spreading. So earthquake also, if the earthquakes occurs at focus, then the earthquake, that shaking will spread in the form of waves. And those waves are called as seismic waves. Waves that transmit the energy released by an earthquake. They carry the energy released by an earthquake. And the farther they travel, lesser the energy. So if they travel more distance, their energy decreases. That is the reason if you are far away from the focus, then the damage due to an earthquake will be less. Got it? Okay. So those were what? Those were some interesting terms. Okay, in very important terms. Focus, epicenter, fault and seismic waves. Got it? Okay, good. Now we'll go into something called as seismograph. Now what is seismograph? Look at this. It shows you what is seismograph. This itself is seismograph. You can see a roll of paper. Right? What happened here, everyone? What happened? It'll again play. Don't worry. See here the paper is rolling and a needle, a pen-like thing is just drawing a line. It's drawing a line due to ink. And when waves, which waves? Earthquake waves strike it. Or when it shakes, what happens? Then on the graph, on the paper, there will be what? There will be a disturbance. There will be like graph-like thing. You can see it here. The wave is coming, shaking. Another wave is coming, and again. Right? So, seismograph records what? Records earthquake. It cannot predict earthquake. If earthquake comes, it records it. Earthquake came. Okay? Okay, good. So, a seismograph or a seismometer is an instrument used to detect and record earthquakes. Detect, not predict. Predict is in the future. Detect is in the present. If earthquake is happening now, if I look at the seismograph, I can say, the line is not straight, that means there is an earthquake. So it can detect and record, keep a record of earthquakes. So remember the word seismograph. Generally, it will consist of a mass attached to a fixed base. Okay, so this is the weight or the mass. That's what you're talking about. During an earthquake, the base moves and the mass does not. So this will remain stationary, but the base will shake. So due to the shaking, what? This random pattern, this pattern will be recorded on the paper. Got it? So you can see a simple example. I've given you a practical example here. All these lines, normal straight lines will mean nothing happened, no earthquake, nothing. But in between you can see at a region it is not straight line, it is like a wave. That means for this part to this part, earthquake has occurred. We have another example also, this. Now if you compare this and if I compare this and this, there is a difference. What is that? Here the graphs are huge, the waves are huge. What does that mean? That means in this case the shaking is huge, the earthquake is more powerful. The earthquake is more powerful in this case. In fact, yes, if I look at the earthquake, it was in Japan on 11 March 2011, but the magnitude is 9.0, and in the previous case the magnitude is 6.3. 6.3 and what? And 9.0. This is a very powerful earthquake. So seismograph also tells us how powerful an earthquake is. How powerful an earthquake is. Okay? Good. Now there is Richter scale. Right, but I think we'll go into Richter scale in the next class. Okay? So for now we understood earthquake, how earthquake occurs. We have learnt about seismograph. Okay? So please do understand how earthquake occurs, the terms and all. Okay, so thank you. Thanks a lot.